Okay, so day 2 on linearization or linear approximation. So we're going to be using linear approximation to find the value of 38 to the 1/2 power, or we all know that that's the square root of 38. Okay, so this is one of the original uses of linearization. It's to actually approximate values of our transcendental functions. Okay, and then we're going to use a calculator to check the results. So again, we're going to be using linearization, which is basically this function right here, L of x equals f of a plus f prime of a times x minus a. Okay, so this directly goes back to what we've learned before when we did tangent lines. So this is our point slope formula. Okay, and we found x1. Well, in this case in linearization, that's a. And then we found y1, which is our f of a. And then we found our slope, which is f prime of a. Okay? The other thing we need to do this is to figure out, well, what is f of x? Well, how do we find f of a and f prime of a if we don't know what our function is? Well, this tells us right here. The function we're going to be using, okay, our original f of x is the square root of x. Okay? So, because we're trying to find the square root of 38, the function we're going to be using is the square root function. Okay? Now, the hardest part about what we're about to do is figuring out if I'm going to approximate the square root of 38, where am I going to linearize? Where am I going to set up my tangent line to do this? Okay, so yesterday I told you where to set it up. So like yesterday in our examples, I said, hey, we're going to approximate, say 1.1. I want you to linearize at 1. Because 1 was the closest number to it, a whole number, to what I was going to do. Same thing, that's kind of the idea here. If I asked you to, in your head, approximate the square root of 38, how would you do that? Well, the first thing you think about is, well, 38 is close to 36, right? Because I know what the square root of 36 is, right? The square root of 36 is 6. So the square root of 38 would be 6 point something. We know for a fact that this number's got to be between 6 and 7. And since 38 is close to 36, it's probably closer to 6. So we would probably in our heads logically think that this number is probably going to be somewhere around like 6.1 or 6.2, somewhere close to 6. Well, that's giving you a clue on where to linearize. I want to linearize and create my tangent line equation at 36. So that is my A. I'm going to linearize at 36 so that I can approximate 38. So A is, in this case, 36. Okay? So if my A is 36, that means my f of A, so this would be f of 36, and my function is the square root, so the square root of 36, which is 6. So that's my f of A. Now we got to figure out f prime of a. Well, that means we need to find out what f prime is first. So if f of x is the square root of x, that means that f prime of x is 1 over 2 square root of x. So in this case, f of a, or f prime of 36, is going to be 1 over 2 square root of 36. And when you simplify, you get 1 over 12. So that is my slope. Now we plug everything in. So we come back over here. L of x is going to be equal to 6 plus 1 over 12 x minus 36. Okay? So that's my linearization equation. Okay, so we're going to use that linearization to approximate what 38 to the 1/2 power is. Okay, so come over here. So L 38. So plug it in. 6 plus 1 over 12, 38 minus 36. So you get 6 plus 1 over 12 times 2. That means you get 6, 2 times 1/12 is 1/6. Which means this is 37 over 6. Okay? Now, which is what we thought, basically 37 over 6 is approximately 6.1666 repeating. Okay, so if you plug this in the calculator, that's what you would get. Okay, and here's the other crazy thing, is that, remember when we said that we knew that our answer was going to be in between 6 and 7? Well, look, right here. When I set up my linearization equation, basically it's saying that I'm going to take 6 and then add this amount right here. That's what we said when we were doing it in our head. Said, oh, it's going to be 6 plus a little something. This part that we did right here using the slope, that was finding that extra little something. So when we did this, that's what we found right here. That little extra something was that adding that 1/6. Okay? So basically, L of x, L at 38 is approximately 666 repeating. Okay, so that's my approximation for basically the square root of 38. If you go to your calculator, and that's what it asks you to do, is to double check it in the calculator. The actual square root of 38 from the calculator gives me 6.164414 blah blah blah. So basically our linear approximation was accurate up to the 1,000 place. Well, technically to the 100 place. It changed at the 1,000 place. That's pretty accurate using a line to approximate a root. Now, the farther we got from 36, the worse the approximations is going to be. But you can see it's still pretty close. And this was one of the designs of linearization.